So today we're going to go through and I'm going to actually do number 1 and 3 from your homework, and they are using the drag formula. So I'm going to put that drag formula up in just a second, but I'm going to first launch you. You should be on module 4, lesson 1, and we are looking at, this is the very first example, so I'll do number 1 from your homework here, and then I'll pop over to the actual assignment and do number 3. So it says an F-22 pilot is flying at 1,538 kilometers per hour at 2,734 meters. She hits a turbulent air pocket and needs to decrease the drag of her plane to stabilize flight. And then we're going to select the action and the reason here. So for number 1 here, if you want to decrease drag, what would you need to increase? This is where you're thinking about the two different flows of the plane. So we have here, if you want to decrease drag, which is pulling the plane backwards, you would increase your thrust. So to increase thrust, we would be increasing our velocity. Okay, that's the velocity or the speed. That is how we would increase thrust. So the action is number 2, which would be to increase your velocity. And the reason is to counteract drag, we would have to add more thrust, which is increasing your velocity. Okay, so now I'm gonna pop over to the actual assignment. Let me find it here, and I have a few things open, but here it is. So action here, I would write increase velocity. Number 2, increase velocity, and the reason is we would want to counteract drag with thrust. Moving on to number 2, you will actually go through, and now it talks about increasing lift. You're going to have to think about what your action and reason is for that one, but I have inserted the equations here for you guys to see. So I have the drag coefficients here as well as the drag equation. I'm going to do number 3 with you, and then the rest of them you'll use your time to go through. It gives you the various aspects as well, and you will be using these formulas in order to calculate drag. So the first one says, a recently designed aircraft wing is operating under the conditions like these following specifications, and what we are going to do is calculate which option best describes the drag forces produced by wind. So I know that with these specifications, what I want to know is the drag. Now, luckily, I'm actually given the coefficient of drag here in this problem. So that is that helps a lot because I can go ahead and plug it in here. In some of the other problems that you guys will be examining, you're actually going to have to go through and calculate the coefficient of drag first and then use the formula to work backwards. But just know that that is how we are, what we're looking at today. So for this first one, I'm going to pop over to my camera so that you guys can see my work here with my calculator. So I have a calculator, I have my piece of paper, and I'm gonna start using the drag formula. So drag is equal to, in this one, I need my coefficient of drag. My coefficient of drag is right here, which is 0.074. Okay. I'm multiplying that times my A. Well, what is A? What is A? If I look here, A is my wing area. So I go down here to find where my wing area is, and there it is. It is 350 meters squared. Now, I have this P right here. Remember, this is the funny looking P. It actually is for density. So I'm looking down here to see if there's anything about density. I see pressure, and then I see right here, the air density is 0.45 kilograms per meter squared, or cubed, I'm sorry, density is cubed. And now the last one I have up here is my V. V is velocity of the plane, the velocity. So I'm gonna look in here to see if there's any kind of velocity, and it does. It says flying at 84.3 meters per second. And we're going to square that. So we're going to square that value. Okay, so now I take all of that and in my formula, I divide by 2. Now it's just being very careful with my math, and I'm going to use my calculator for this. So I will say that for the purposes of this class, I'm for sure going to write down, I'm going to still have my 0.074 times 350 times 0.45, but I'm going to take this 84.3 and I'm going to square it to get 7,106.49. And then I'm going to divide by 2. Okay, so I have that 7,106.49. I'm going to now multiply times 0.45. I'm going to multiply times 350 and 0.074. I have to take that number and divide by 2, and I get 41,413.07 newtons. Okay, so drag is 41,413.07 newtons. The closest to that is number 4 here. Number 4 is my answer, and I would want you to see the work. I say work for drag forces, but there is my work.